Hello everyone. Okay, so now this is going to be section 4.1, 4.2. I will be combining two sections in this lecture, like I said in the last video. So this is going to be Monday lecture. All right. And again, before I start this lecture, I just want to remind you guys about the web assigned homework. So the web assigned homework of section 3.9 and 4.1, 4.2. This one is I'm covering today. Okay, 4.1, 4.2 I'm covering today, and 3.9 I covered it last Monday. So the web assigned homework for these two will be due this coming Saturday, which is October 17 at 11:59 p.m. All right, so make sure you guys do this. And also, if I assign any quiz in this video, like normal, as usual, it's always due the next day, right? So since this is a Monday lecture, so that means if I send any quiz in this video, then it is going to be due Tuesday, tomorrow, right? Okay. Okay, let's start this one, 4.1 and 4.2. So let's start with the area. Okay, so area here is going to be related to the integration or integral. And if you remember the last video 3.9, if you haven't watched that video, please watch that one first, because we are going to use this one 3.9, the one I covered last Monday. So please watch that one because we will be using some technique from that videos as well. So it is required to watch the videos. All right. So integration, even I mentioned that in the last video, it's same as antiderivative. All right, so yeah, please watch the video where I've talked about the antiderivative technique. So these two are basically same thing. All right. Okay, so now here, when you're talking about the area, let's say we are looking, okay, we have a graph. Let's say this is f of x, this is x, this is y. And this graph is, let's say it's in between this interval a and b. Okay, and now we are trying to find the area so area enclosed by this graph, which is f of x graph, area enclosed by this graph in these two intervals. So here the area, or A, this capital A, the area of this region is same as the antiderivative of this function in the interval this interval. So interval A to B. All right. And the antiderivative, like I said, it's same as integration. All right. So I can also say that, okay, so antiderivative, the way we write the antiderivative, the exact way of, or the mathematical way of writing antiderivative for integration for these kind of conditions, well, we can say, okay, this it's like this. Okay, this is an integration sign. And now since we are saying the area is going to be in this interval, so that interval, which is an x-axis, okay, so that which is an x-axis, so that interval is going to go here. So from left to right, the left is going to go down, so A, and this right interval or end point is going to go on the top. So that means our interval is from A to B. All right, and we're trying to find the area of this function. So that function is going to go here. And since we are, well, this interval is in this x-axis, so that means we are taking the integration or antiderivative in terms of x, so that we're going to write dx. And the reason we have x here is because we are looking the interval a to b, which is an x-axis. Okay, so this is how we write the integral, all right, or antiderivative. Okay, and so Yep. So, and also integral. So what we can say from here is that, so the integral or something like this is also means the area, right? Okay, so that means let's say again, this is f of x, and this on x-axis, this is, let's say, a, this is b. So here the area enclosed by this and the x-axis is going to be this region, right? It's not this region because this, well, basically this line is going towards infinity, this line is going towards infinity, so we cannot really find the area of this region, right? But here this thing is enclosed by x-axis and this graph, right? So now in this case we can find the area. So the area is going to be the integration from left to right. It's a to b of this function, which is f of x, and since this one is an x-axis, right? So d of x. All right. Now the thing is, if you compare this graph and this graph, well, you see that this graph is above x-axis, right? And this graph is below x-axis. So here, that means our area here, we need to consider area here as a negative area, okay? Because this area is enclosed below x-axis. Clear? Okay, so that's the basic idea of finding area using the integration. Well, actually I have one more. So then let's say we have this graph and we have another graph. Let's say this one on the top is f of x graph, this one on the bottom is g of x graph, and let's say both of this we are finding an interval a to b. This is x-axis, this is y-axis. All right, and then let's find the area of this middle region that is enclosed by f of x and g of x. All right, and let's find the area of this region. How are we going to find the area of this region? So in this case, what we can do is first we can find the area of f of x on this interval, which will give the area of this whole thing. All right, and then subtract the area of this whole thing by this area, right? So this area I can find using g of x, right? So basically what I can say here is the area A, this area in this case is going to be the integration from a to b of f of x in terms of x minus, so we have to write dx, right? And minus, so that, well, this one will give the area of this whole thing, right? Whole thing, and subtract the area of this bottom one. So that one I can find a to b of g of x dx, right? So yeah, basically with this equation, we can get the area of this region, okay? So yeah, try to understand this concept. I might ask something related to this, the idea related to this in the exam, right? Okay, now let's do some examples. Let's do some integration examples. So, okay, so now so far I have just said f of x, but I didn't really mention what exactly the f of x is going to be, right? Now let's look at the exact problem. All right, so if you see here, I said if you see this, I said here area and indefinite integral, right? So the in I'm sorry, this I was trying to say definite, not indefinite. Because indefinite integral, I will be doing that later on. This one is going to be definite integral. Okay, so the definite integral is basically, it's similar to what I talked about the area. So basically here, the definite integral is basically, if you have the interval defined, then those kind of integral, or these kind of integral, we call it definite integral, right? Because the interval is defined. You will see later on this kind of integral where you won't see any interval. All right, so these kind of interval is called indefinite integral. All right, this one is called definite integral. This one is called indefinite integral. All right, but for right now we'll be just doing definite integral. Okay, so the definite integral. Okay, let's find the integration of, or we can even say antiderivative, right? The antiderivative of x squared, right? So this one means the integral, right, or antiderivative. So the integral of x squared, and let's define the interval. So let's say 1 to 2 df x. So you will be saying this thing now. You need to find the integration of x squared. All right. So if you go back to previous section, or section 3.9. So the antiderivative or integral of x to the power n, when you integral this, or when you take the integration of this, we call this x to the power n plus 1 over n plus 1, right? And there I said we need to see, right? So the only time we need to see is if we are dealing with indefinite integral. Okay, so so like I said here, oops, like I said here, this is indefinite integral, right? So this is, well, where we don't have any interval, then we call this indefinite integral. Where we have the interval mentioned, this is called definite integral because we have integral defined. Oops, definite. Okay, but since we are dealing with the definite integral, we don't need this c. All right. So first, let's find the integration of x squared here. So x squared is going to be x to the power 2 plus 1 over 2 plus 1, which is 3. Okay, now after this, since we have an interval, so what we're going to do on this kind of problem where we have this interval is we're going to make a line on the right hand side like this, and then write this interval here again, 1 to 2, like this, right? And okay, now here we can even say 2 plus 1 is 3. Okay, so after this, what we're going to do is, okay, from the top, well, plug this value here, okay, and minus plug this value here again. So what I mean here is, okay, plug this to here, so which will be 2 to the power 3 over 3 minus, and after that, plug this value here. If you plug this in here, it will be 1 to the power 3, which is just 1, divide by, or yeah, divide by 3. This is 1 to the power 3. Okay, so this is how you're going to deal with definite integral, all right, where an integral is defined. So now 2 to the power 3 is 8 over 3 minus 1 over 3, which will give 7 over 3. All right, so yeah, when you have this indefinite or definite integral like this, then you will be getting the value at the end. When you have indefinite integral like we did in 3.9, then Once you take the integration, then you write plus c. All right, so make sure you understand the difference or the way of approaching for these two kind of integral. All right. Okay, now let's see some properties of integral. So let's say if you're taking the integral c times f of x, where c is a constant. All right, c is a constant. That means c can be any number. All right, so in this case, if you're taking the integration, whoops, I need to write d of x here because I'm taking the integration in terms of x. Okay, so now in this case, this constant will just come out. So c, and just multiply this c to whatever value you get from this integration. All right, that's one property. Another one, I have done this in the last section as well. So if you take the integration or antiderivative, whatever you want to say, of a constant, then this, in this case, will be getting, well, if you're taking constant, then it will be c times, since we're taking the antiderivative or integration in terms of x, so that's why we'll be getting x here from a to b, right? And this is also same as after this, we just plug this in here, right? Like I did in this example. So the c will stay there. So plug this value here instead of x, which will be b minus, again, c, and plug this a here, which will give a, right? So now from these two, just factor out c. So c times b minus a. All right, and another one, if you're taking the integration of, let's say there is a function plus minus, there can be either plus or minus g of x, something like this, then we can basically distribute this integration for this equation, for these two equations. So it will be same as integration from a to b of f of x dx. So it can be either plus or minus, again, integration from a to b of g of x and dx. All right, so yeah, simple idea so far. Okay, there is nothing complicated, I think. Okay, let's do a simple example based on some of these ideas. Okay, so let's say, or let's find the integration from, oops, it looks like s, but it's not exactly s. All right, it's going to be a slightly bigger than like a normal s, the extended version of s, something like that. All right. Okay, let's say the interval is from 1 to 2, 3x squared minus 2, and let's take integration in terms of x. All right, so here, okay, like I showed here, so if you have a two function with plus minus, or either plus or minus in the middle, then I can basically distribute this integration for these two, right? So I can even write integration from 1 to 2 of 3x squared dx minus integration from 1 to 2 of 2 dx, right? So now from here, I can, well, just take the integration of this, or 3x squared. So 3 is a constant. I can just pull out 3, just take the integration of x squared, which will be x to the power of 3 over 3, right? Because x to the power 2 plus 1 is 3 over 2 plus 1, right? And from 1 to 2 minus, if you take the integration of a constant, then it will be just 2 times, since you are taking the integration in terms of x, so 2x, right? This is, yeah, this one, right? The same idea. Okay, now, again, it's from 1 to 2, right? Okay, now for this 3 and these two are gone. So from here, well, we just have x to the power of 3 from 1 to 2 minus 2x from 1 to 2. It's always, this value is always going to go on the bottom, and this value is always going to go on the top. Make sure you don't write one on the, if you write 1 on the top and 2 on the bottom, that's going to be wrong, all right? So be careful in this. Okay, now, okay, so for this one, okay, first you plug this in here, or since we have a sim interval, right? So we can even write it like this. Just combine this, x given negative 2x, and let's just write just one interval, because it has same interval, or same interval, right? Just because this two has same interval, I can basically just combine this to a single one interval. Anyway, now plug this 2 here instead of x. So if you plug this in here, it will be 2 to the power of 3 minus, well, 2 is going to go here as well, so 2 times 2. All right, so okay, now minus, and after that, now plug this 1 here instead of x, minus 1 to the power of 3. This one is this minus, so minus 2 times 1. So from here, I get 8, and here I get 4, minus, okay, if you distribute this one here, it will be minus. If you distribute this one here, it will be, okay, this one is minus 1. If you distribute this one here, it will be plus 2. Okay, so here, 4 plus 1, that's 5. All right, so yeah. Okay, so you get the answer, right? So yeah, basically this is the idea of finding the integral when we have equation like this. Okay, later on other chapters, we will be doing more complicated examples of integrations. All right, so basically this lecture was mainly focused on the idea of the integrations. All right. Yeah, make sure you do your homework on time, which is this Saturday. I'll see you on the next video. All right. Thank you.